problem?
No,
Found any
sir.
problem there? Huh? No. Sir Yogesh, have you seen? Somsekhar and Yogesh. Yogesh, are you with me? Yes, so we'll start. I will share the screen and the paper so you will understand. Pooja, my voice is clear, Pooja?
Yes, sir.
Okay, okay. So you can see the screen. Who is there? Vishal?
Hello.
Yeah, yes, Vishal. My screen.
Yes, sir. But
Voice is not clear.
here network issue.
Network issue is there. Okay. What about Prashant, Mayuri? Mayuri, Supriya?
Yes, sir.
Okay. My voice is clear.
Yes, sir.
And you can see the screen. Okay.
Yes.
Last lecture, we have already discussed about the things of Piper nigrum, which is the case study of new amide alkaloids from the roots of Piper nigrum. In that, we have already discussed about the part which is abstract. Okay. In that abstract, we have understand that there are 7 new amide alkaloids are there. Then also we saw these 7 structures which is newly synthesized or newly reported in this paper. The name of this paper is Journal of Natural Product. Journal of Natural Product. Okay. Then as a case study, we have started to learn about this first structure. The name of this first structure is, we have already discussed. Then yesterday we have given the numbering. So what is the number for this carbon? If you can see the share screen. What is the number for this one?
1.
1.
1, sir.
The 2. Here is the
2.
Here is 4, then 5, 6, 7, 8, 9, 10. Okay. Then nearby nitrogen, there is another 1 number. We have given
1 dash.
1 dash. Then here 2 dash. Then 3 dash and 4 dash. Okay. Vice versa. Here 3 and 4, we can exchange it because both are the similar. Based on that, we have also discussed yesterday about compound 1 from this one. Okay, so how many carbons are there? Primary carbons are there. See, the presence of 3 methyl groups. 3 methyl groups are there, which they are. This is 10 number, this is 3 number, and this is 4 number. Okay, 3 primary, 3 methyl groups are there. Then 7 methylenes. Methylene means CH2. 7 methylene. So where they are methylenes? 1, 2, 3, 4, then 5, 6, and 7. Correct? You can visible this my pointer. Pointer तुम्हाला दिसतोय का?
Yes. Yes, sir.
Okay, so based on that you can imagine it. And then also we have discussed about the 2 quaternary carbons, which is C1 and C5. Where is the quaternary carbon? This one. This is C1 and this is C5.
Carbonyl carbons.
Yes, carbonyl carbon is known as quaternary carbon. So how we have to provide the another data, which is confirmatory data based on this table. In this table, you can see correctly, there are the carbon and hydrogen. Carbon having hydrogen, the number is 1 to 1 to up to 4 dash. Okay. So if one number carbon is there, which is here. Okay. So what will be the proton NMR peak here?
No proton is there.
No proton is there. So see here, there is no proton NMR spectra. Here, absence of spectra you can see here. Understand? Let me check whether I have highlighter. Yes. Then I can draw it. Yes. See, in this position, there is absence. Okay. So this is the one thing. The second thing, with this first carbon, we have discussed about this first carbon now. Then first carbon, what is the carbon 13 value? See, here you can see the carbon 13 value. Okay, delta C and delta H. So you can imagine delta H is belongs to proton NMR and delta C is belongs to carbon 13 NMR. Okay, and this is the depth value. Okay, based on DEPT. Hope you have already studied DEPT in your spectroscopy, and if you not, try to understand it. Okay, from DEPT we will understand whether this carbon are secondary, tertiary, or primary, and so on. Okay, so based on that, then this first number carbon is quaternary carbon. The value of carbon 13 is too high. Okay, and which is 175, which is 175, right? Then we'll discuss about the 2 number carbon. What about the 2 number carbon, which is methylene now? So methylene will have how many proton here? 2 proton, right? 2 protons are there. Okay, so based on that, there are 2 values. One is 2A and another is 2B. So 2A it will show 2.71 and 2B it will show in 2.5. काय थे 2.5, 2.7? These are the delta value which is collected from the proton NMR spectrum. From the proton NMR spectrum. Yes. So this is about 271, 250, and we have already discussed number 1, then 2 and 2. Okay, so these 2. Then what about the third number carbon? Okay, third number carbon will have again 2 protons. Okay, you can imagine it, these 2. So again these 2 hydrogen will give the 2 different peaks. Okay, 3A and 3B, and their value is 2.3 and 2.1. And what is this DDT? Who will explain? Who will explain the DDT?
Doublet of doublet of doublet.
Yes, doublet of doublet of doublet. And this M is belongs to multiplet.
Multiplet.
Yes. And what are these values? 17, 10 and 5.
Coupling constant.
Coupling constant with J. Okay. These are the 3 coupling constant. Right. Then the another thing, yes. And the carbon 13 value for 2 and carbon 13 value for 3 number carbon is nearby 30. Why is it so? Because whatever I have learned is for primary carbon 13 value are always less than 50. Sorry. Always less than 50 for primary. Secondary is in between 50 to 100. tertiary is 100 to 150. I'm talking about carbon 13 values, okay? And quaternary carbon is 150 to 200. You know this rule? And
Yes, sir.
yes. This is general rule, or we can calculate randomly. Okay, this is not hard and fast. We have to follow the same. Okay, but please try to imagine accordingly. Okay, primary, secondary, tertiary, and quaternary. So this CH2 is belongs to primary carbon. So the value of this one is nearby 30. Then what about 4 number? So we'll check where is the 4 number, this one. So how many protons are there in 4 number?
0.
No proton. So the proton NMR value is, it will not be there. Then same with the 5 number carbons. Then for 4 number carbon, carbon 13 value, okay, is 92. And the quaternary carbon, the 5 number carbon is 209, right? So you can plan accordingly. Then we'll discuss about the 6 number. Then what about 6 number? 6 number is again CH2. 6 number is again CH2. So it will show the value of proton NMR is 2.48. The carbon 13 value is 35, and which is CH2. Then 7 number, it will show the 2 peaks. Okay, again which is CH2. So now you can imagine 7 number, 8 number, 9 number, and 10 number. How 10 number will be? 10 number, see, 10 number is very less delta value, which is 0.9. Okay, only one J value will be there, and the carbon 13 value is very low, which is only 13.8. Okay, and the DEPT, which is primary, it shows CS3 value. Then what about 1 and 2? 1 dash actually. 1 dash, 2 dash, 1 dash is again here. Okay, there will be a 2 protons. It will show 2 different peaks. One is double doublet, another is multiplet, and the carbon 13 value is nearby 48, and which is CH2. Then what about the 2 dash? Where is the location of 2 dash? Now here. Okay, how many protons are there? Only 1 proton. So which is giving the septate peak, and the 2 coupling values, and the proton carbon 13 value is 27.9. It is CH. Then 3 and 4 dash, both are almost equivalent. Okay, doublet. Then carbon 13 value is 20, and both are CH3. Okay. सर रेकॉर्डिंग सुरू आहे आणि लेक्चर सुरू आहे माझं. मी एक 20 मिनिटानंतर 20 मिनिटात. Okay, so CS3 and CS3. CS3 and CS3. Okay. Then what about the OH? So OH is also there. OH is also there. Then this OH you can find which is active in proton NMR. Okay, and the OH peak in proton NMR you can find it on 4.9. The delta value of OH is 4.9, and what is the multiplicity? Which is S. So means only singlet. Okay, so we have discussed accordingly the depth value, carbon 13 value, as well as proton NMR value. Okay, so I will ask with whom? Mega. Mega.
Hi, sir.
Yes, yes, yes. Do you understand what we have discussed now?
Yes, sir.
Okay, Sandhya.
Yes, sir.
Okay, okay. No problem.
समजलं.
Yes, yes. Great. So now we will move to the next part. Okay, next part is um, this is all about the accordingly same you have to think on the carbon compound 2 now. So compound 2 everything is provided in this paragraph. Okay, so how many characteristics are there, then proton NMR peaks and everything they have provided in this paragraph. Okay, then compound 3, I think compound 2 who is going to explain is Vikas. Compound 3 is going to explain is Sonal. Compound 4 is going to explain Mayuri. Compound 5 is Shubhangi and so on. So how you will get the data of proton NMR? Vikas and other, you can see here, this is the carbon number 2, compound number 2. H1 NMR spectral data of compound 2, compound 3, compound 4A, compound 5A, compound 6, compound 7. So there are uh, number of carbon or hydrogen. Okay, so one number hydrogen, there will be no peak, then two number this peak and so on. For compound 2 you have to discuss this one, compound 3 like this, compound 4 like this. Okay, so everyone has to study only one compound like this. Hope you understand. Then carbon 13 value is also same. See here, this table number 3 is specially for carbon 13. There you can find the carbon number 1 to carbon number 5 dash up to. So this is for second compound, third compound, 4A, 5A, 6 compound and 7 compound. Okay, so compound 6, how they have isolated and so on. This is the common scheme for everyone. This is the common scheme for everyone, how they have synthesized it. Then we'll discuss about the experimental section. In this experimental section, you will find that general experimental procedure. So I will open the okay. See, uh, now we have started to discuss about this one, which is this compound. Okay, compound 1. So accordingly you can discuss about compound 2, compound 3, compound 4, compound 5, 6 and 7 up to whom? Priyanka, right? Then yesterday we have discussed about compound 1. Then what about the numbering of compound 1 and what are the location, which is the methyl group, which is methylene, which is sp3 hybridized, and which is quaternary. So we have discussed. Also, just now we have discussed about the proton NMR value, carbon 13 NMR, and DEP. Okay, same I have taken from the paper through this PowerPoint presentation. Then okay, this we have discussed. Now, the general experimental procedure. First, they have also characterized through UV spectra, and UV spectra they have used. This is common for everyone to us. So, Simanju is a name of a company, the provider of UV spectrophotometer. Okay, we have in our college we have the same type of spectrophotometer. The name of company is Simanju. Okay. So this spectrophotometer they have used to characterize it. They have calculated also IR spectrum using JASCO is the name of company. Okay, and this FTIR, how they have prepared the sample by KBR disk method. There are two type of methods available to calculate the IR spectra. The one is KBR disk method, means पोटॅशियम ब्रोमाइडची अशी डिस्क असते, त्याच्यावर कंपाऊंड घ्यायचा आणि स्पेक्ट्रा कॅल्क्युलेट करायचा, राईट. So they have used this one. And another method which we have the IR spectrophotometer again from Simanju, and we can directly keep our sample on the IR spectrum and we can monitor it. Okay, so we have very advanced version of IR spectrophotometer. Then next characterization is optical rotation. They have also measured the optical rotations using JASCO. This is the model number of digital polarimeter, and cell which they have used is 0.5 dm cell. They have also characterized EIMs and HREIMs were taken on this spectrophotometer. What is the use of it? I don't know it. Okay, but they have also characterized it.
Mass spectroscopy.
Not directly. Mass is here. Mass is FABs and this one. This is belongs to mass. But I think here I am not sure. But I think some ionic compounds they used to calculate using this type of spectrophotometer. Okay, so let's see if we have done the Google also, we will understand. Then FABMS and HRFABMS were taken on Geol JMS. This is MS station spectrophotometer. We can calculate M by Z ratio using this one. Then the next one is proton and carbon 13 NMR spectra were measured in this company instrument having 500 and 400 spectrometer. This is 400 and 500 is the megahertz capacity of that instrument. And the solution, the compound which they have prepared is using CDCl3 solution with TMS, which is trimethyl silane as the internal reference, and chemical shifts are expressed in delta value, which is in ppm. Okay, so this is common to all of us. Then the last two characterization, which is reverse phase HPLC separation, they have carried out using JASCO type of HPLC, and what type of detector they have used and so on. Then next characterization, which is reverse phase column chromatography, RPCC, and which is measured through the silica gel having mesh size 100 to 200, and then this is the institute where they have done this characterization, and where silica gel was carried out using a CCl gel having the mesh size is 200 and 300 purchased through Merck industry. And the last, the TLC, thin layer chromatography, was performed on CCl gel 60 plates. These are the plates provided by the Merck company. Okay, so this is the common format. We should know how people used to characterize it, how many instruments they have used it, and how they have characterized. Okay, then what type of material they have used. Directly we cannot say we have taken this Piper nigrum. Okay, but this root of Piper nigrum used in this study were collected in Hainan Iceland, या बेटावरून घेतले, which is People's Republic of China. The place which is present in Republic of China, when in April 2001 an identified by and voucher specimen is deposited in the herbarium of Toho University, Japan, and so on. So this much detailed specification which we have to provide for the publication. And the last thing which we have to learn is extraction and isolation. So they have taken the plant material, they have characterized it, but how they have extract and isolated from that Piper nigrum or that miri. So the dry powder roots 7 kilogram were extracted repeatedly with 70% methanol, right? At room temperature. The aqueous methanol. What is this 3L into 4? 3L into 4. Can we imagine?
3,
Return?
3 liter
Yes, 3 liter.
4 times.
Yes, no. Here repeatedly means पुन्हा केलेलं आहे. 3 लिटर मिथॅनॉल मध्ये याचं एक्सट्रॅक्शन केलेलं आहे. आणि किती वेळा केलेलं आहे? 4 टाइम्स केलेलं. So at room temperature. Then aqueous methanol extracts were combined and evaporated under vacuum to give a residue 508 gram. The residue was dispersed in H2O 1 liter, then extracted successively with chloroform 1 liter, ethyl acetate 1 liter, and N-butanol saturated with H2O. The solvents were evaporated in vacuum pump and the chloroform extract was chromatographed by silica gel. So this is the standard procedure of extraction and isolation of these alkaloids they have used for this research. Lastly, the compound which we have mentioned, the common name for this compound 1 is piperacilliamide, which is colorless oil having optical rotation is like this, and which is soluble in chloroform. In IR value, they used to use the KBR disc palette, and the maximum what the value of IR it was shows in 2439. This is the first peak. This is second peak, third peak, fourth, 5, and 6th. So these are the 6th characteristic peaks the shown by the IR value. Okay, so this one means this 3439 is belongs to amine. This 1675 belongs to C double bond ON, and this 1457 is belongs to this. Here 3439 is again belongs to OH, because OH peak is also there. Okay, OH correctly. This is OH. This is CONH. Then this one I think 1450. Can we imagine to see our structure? 1450. Because carbon double bond carbon is belongs to 1600. So less than that may be carbon single bond nitrogen. Maybe this one. Okay. And then these are the not that much characteristic. Okay. Then the proton NMR, which we have already learned in table 1, they have dissolved the samples in CDCl3, and the 500 megahertz instrument they have used for the carbon 13, also CDCl3 solvent, and 125 megahertz instrument they have used. And then this FAB technique they have used for the mass spectroscopy, and they found that the mass value M by M plus ion or M by Z ratio, which is 256. And then this is this instrument we were talking about has calculated correctly the M by Z is 256.19. And the last calculation from Cal CD, which is molecular formula calculation, and the molecular formula for compound 1 is C14H26NO3, having this molecular weight. So I hope you understand what we have explained through this journal of Journal of Natural Product. And these are the references. Some references I have put over here from reference 1 for writing of introduction they have used, which was published in 1984. Then this second reference, they have given so many references in between from 1997 to up to 2003, right? So many related publications they have uh, here cited, is called as the citation. Okay, so they have cited so many research papers. Then third, which is again 96, this one 96 and 1977, and like that, I think more than 30 references are there. So again, I will share the directly the paper where it is. Okay, so this paper was there, which was published in 2004, and in our syllabus they have added for the case study. So I have given for the compound 1 and their introduction. Accordingly, you can prepare one by one from 2 to up to 39. Okay, so this is all about. If you have any questions, before to ask question, I would like to share another thing, which is supporting information of this paper. So this today I will share with you. So this is the supporting information from the same paper, which is Journal of Natural Product and supporting information. There you will find the structure of 8 number. Okay, 8 number, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 29. म्हणजे तुम्हाला मी 20 पर्यंत ऑलरेडी दिलेलं आहे, पण ज्यांना पाहिजे त्यांनी त्याच्या पुढचे कंटिन्यू करा. आणि अप टू 39 ऑल स्ट्रक्चर्स दे हॅव प्रोव्हाइडेड इन अनदर पब्लिकेशन, and based accordingly again they have also mentioned 8, 9, 10, 11, 12 compound and their proton NMR values. Same the 13 to 17 their proton NMR values. Same 18 to 23 and their proton NMR value. Same 24 to 29 up to 39 all proton NMR values. And then they have also started the carbon 13 value as well. Okay, from 8 compound 8 to 23 and 24 to 39. Okay, so this is all about the supporting information, right? So using this information you can prepare your assignment, and which is for 10 marks to everyone. And okay, so case study of Piper nigrum. And tomorrow lecture I would like to share the another paper, again the another case study of the natural product, and then we'll declare the this I would say the section number 2, which is biogenesis. Then we'll move for the section number 1. So ask some question if you have.